So what we're going to do now, because we have lots of time, I think, is we're going to go back to our roundtable discussion. And the nature of this is anybody can ask anybody anything about anything, hopefully about the topics at hand. We were talking a little bit earlier about commercialization, so that's right up your alley too. And Gilda, I'm glad you're back. That's awesome. So I think, Sarah, I don't know if you have anything you want to comment as our discussant at this point, or, again.
Yes, I do have a question, and it's, I'm going to target Bar right now, but for any of the rest of our participants who have been in this tech transfer cycle, as a young faculty member, and then as with a startup company, how do you balance your life in the context of being a professor and your roles at the university, and then the roles and commitments you have with your startup commitment in your startup company? Can you speak to us a little bit about how you went through that process?
Absolutely. I went through the process, I would say, with awareness. And awareness of like the timing of things, and that everything has to have its own time. And I'll give an example. Like when I started as a faculty member, I knew that I wanted to do tech transfer. So in the beginning, I had conversations with my tech transfer office about how I would balance that and what things made sense for me to patent as a professor and what things that I would do in a business at some point. So that was the start. But then for the next 5 years, kind of building my group, fundamental research, I knew that it was impractical for me to like spend time in the business. So I waited a couple of years to start a business. And then even, after I started it, the first 6 years, I hired Craig, who was a postdoc in my lab after he got his PhD, for him to do it. And I had a guy who was my CEO at that time. He was kind of, I knew he wouldn't be there forever, but he was there. And I knew that I would come out at some point, but the timing for me was key to make sure that I had a business too. I would say this, that I knew that needed a lot of development, needed a lot of IP development, market research, market development. But the tricky part came when after tenure and it was time for me to really get the business going, I actually planned 2 different sabbatical frequencies. I took a sabbatical and I went and I spent time setting up key things for the business, and I raised the first bit of money. And then I got the team going. I hired some people, and then I went back and then I started teaching. And what happened also is that I changed my teaching and started teaching different types of classes. So in addition to teaching heat transfer early on, I taught some graduate courses on nano, things like that. So then I kind of moved to just teaching my special nano classes. And then I started teaching some, Georgia Tech has a Create X program that has like these entrepreneurial lectures. I started adding that into my repertoire. Why? Because it was something that benefited the university, advanced my career in a different way as a professor, but also I could bring some experiences from the business into it that were valuable. And then after doing that for about 4 years, I took another leave of absence, which I've been on now for 2.5 years. So it's been, it's not an easy thing, because I think I had to also make a decision at some point when I would stop bringing on new grad students and when I would let my group get down to a level that I can manage while being full-time in the company. So I don't, there's no perfect thing, but I think the best thing you could do is to actually think about it and have a plan and like try to think about transitions in small chunks of your life.
So if I might follow up, what's the next step for you then in thinking these transitions? Have you given thought to your next transition?
I have. So I, in this last phase of being on leave of absence, I was 50% time. In the 50%, I took an administrative role as the faculty athletic rep at Georgia Tech. So I did that, because I'm a student athlete. I love athletes. Who knew that I would do this in a time when NIL and all the lawyers would be like all over the NCAA. So it was more time consuming than I thought, which is why I stepped away from that earlier this year. In that process, I was part of like thinking about with our new president, how do we build an entrepreneurial ecosystem? And I happen to have a friend on faculty who is the CTO and co-founder of a battery materials company that already is, valued in the billions and things like that. And he already lives in California and Atlanta. And I say, look, we need to create things to keep people who are successful and entrepreneurial in our ecosystem. So I worked with one of the state of Georgia regents to get two new classifications in the state of Georgia. The regent's entrepreneurial faculty member, which my friend has now been named one of the first 4 people to get it, and a regent's innovators leave of absence, which is instead of having to apply for leave of absence every year, that if you raise money, you can have 3-year chunks of it. So I'm going to apply for that and be on leave of absence even longer to kind of help put that in our ecosystem a bit. But I don't know, after 3 years, I don't know. I haven't thought about it. I think, and that's kind of the story for me, is that I need to see where I am, but I needed to help our university ecosystem create something that values that, so that we can together, I can do it, and then people can see that example, and then we could attract more faculty who may want to do similar things.
Yeah, that's fabulous. And I just throw it out. I'm not sure where anybody else in our presenters are with respect to the startup company tech transfer process, but if you have anything to share, I'd like to hear it.
Well, I just have a short joke that Bara kind of made me think of when back in the olden internet days, we would talk about what's the future, where is the future leading us, and what's technology and commercialization and all that stuff. And our joke was 5 years or infinity, whichever comes first.
Right.
That's right.
So
Very good.
I have a question for all of you, and I'm sure it's something all of you have an opinion on. On the one hand, I think one of the things that gets done very well in the United States is the funding of research, fundamental research. But I'm wondering, all of you have received, NSF grants, DARPA grants, and the like. What should we improve in how we do funding of fundamental research and work in universities? Oh, come on.
I'll offer a thought.
I'll take the bait. But first of all, let's recognize that a lot of things are being done well. NSF has the gold standard review process. DARPA is known for taking amazing risks and creating amazing technologies. So there is a lot that is right, but also there is a lot that can be improved. And I'll just point to a few things. One is, to whatever extent that's possible, give program officers at various agencies more encouragement, more leeway to take risks. That is, don't let the panel review process kind of constrain ability to take risks. And when you take risks, there are going to be some things that won't work out. And so to have that tolerance for things not working out, I think we as a community don't like to talk about things that don't work. Right? We only talk about things that work and get published or are successful. But I think having a culture which allows that to happen more, I think would be beneficial. Second area that I think, and this was my sort of last point, is this is like a system which goes from which connects fundamental research, innovation, and technology creation and societal impact. And it's not a linear, slow, it's lots of feedback loops in this system. Frankly, I don't think we quite understand this system really well. And whatever we can do by way of examining it, exploring it, and then improving this system so that it produces innovations faster and connects fundamental research to societal benefits, both more productively and faster, I think would be enormously helpful. I think we have just scratched the surface of understanding this system. So I'll stop there.
Al, Gilda, go ahead.
So,
God
Ed,
bless you.
I'm sorry, Gil. Thank you. Ed, I'd like to offer, I was inspired by Bara's talk, and based on Bara's presentation, I want to offer this thought. There's a lot in the United States. Whoops, my video disappeared. Oh, well. There's a lot that's going great in the United States, and it's all about value creation, getting all the research done, getting the basic rules sorted out, et cetera, et cetera. But where I think we have fallen behind and where we have slowed down is value capture. So value capture is the second half of Bara's story, which is, hey, I moved that stuff into a company. And I specifically mention it as value creation and value capture because all the research budgets are doing a great job at value creation. But who's capturing the value? Is it us or is it somebody else? So I think if we think of it a little bit differently as how do you capture the value you created with your research investments? Then it's a case of keep the research investments strong and varied. And as Pramod and others have said, enable the program managers to take those risks and not be constrained by selection panels. But to really set up a scenario where it's a lot easier for people to take the next step and capture the value. And so, Bara, at my school, we have up to 5 years of entrepreneur leave that you can get. So you can go to Infinity at UC San Diego. And as the dean, I approve these, and I do them quite liberally because if I don't help drive the capture, then I haven't finished my job. So I think if we think in terms of capture, speaking of capture, someone captured Ed's dog.
So I want to build on what Pramod and Al said. I think that part of what we need to do too is broaden the definition of what we consider success, what we would be willing to take a risk on, what the value creation and capture looks like, where you will find it. We sometimes are a bit too narrow and where we think we're going to find good research or what constitutes a good research question. We need all the diverse perspectives so that we can look at who's forming the questions, what frameworks are we using, because who forms the question and what we're studying actually does dictate a good bit about what you get. And I love what Bara's done and what he shared with us, because part of what he showed is like a new way of thinking and doing, a new way of approaching how we deal with a faculty member who's entrepreneurial. If we only use the existing models and we only value what's already there, you would not have the kind of success that Bara has just described to us. So like broadening our perspectives on that and the viewpoints, I think would make a big difference. Go Bara. I remember you when you were a brand new faculty member.
I know it's been a while. My oldest is in middle school this year.
Right?
Yeah, we all grow up. So one of the questions that was came from the audience has to do with, I kind of lump it into engineering responsibility, but a lot of what we do when we do these big engineering projects end up having, a lot of positive consequences, and I'll get to those in a second, but some negative consequences too, relative to pollution and climate change and things like that. How have each of you in your careers, or how are you thinking about that? How are you thinking about, as I look at the work I'm doing, either research or industrialization of it, how are you thinking about impact on the planet?
If I can jump in, for me, I think one of the best things about being a faculty member and then doing tech transfer is, and I tell people all the time, I got married right before I came to Georgia Tech, and I had $70,000 of student loans from Vanderbilt. And it allowed me to establish some financial stability. And that's important because like even this week, venture capitalists called me and, people, now that I've had some success, people offer me jobs and things like that. And it doesn't distract me from the course. And I say that to say that I think that you have a unique opportunity being a professor in the US in engineering with a pretty well-paid job. And if you have a dean like Al that, is supportive of the type of things you want to do, you can plan a path where you get to make good choices about sustainability because you get to not be rushed a lot of times. And it's like, for me, like in my research, we use recycled aluminum foil to make our product. And that was a decision made back in 2009. Even though copper has higher conductivity than aluminum, but it was like, if I'm going to do this, then, and to leave something that's so nice as being a professor, then you might as well do it in a way that does more than just makes money or transfers tech. And I think it's important to be able to tell that story. I think as an undergrad, I didn't actually understand what my professors were doing or like how much professors got paid or the whole model. But I think once people understand it as a pathway to be able to build and innovate and change the world from a somewhat stable position, then it becomes more attractive because the reality of a lot of big successes in startup space and like impact and tech transfer are from people who have financial stability. That's like the greatest secret of Silicon Valley is that a lot of people, the most successful people came from an ability to get money from other people. And so I think, to Gilda's point about broadening things in general, like broadening our definition of success, but also broadening how we discuss the opportunity in tech transfer for being a professor. I think that's important.
Ed, can I?
Please go ahead.
Yeah. So the question you asked has become more and more central to my thinking. I'll just share some thoughts that over the last few years I have explored. Like in today's talk, right? I talked mostly about the positive impacts of the technological revolution, IT revolution, right? But we all know that there are serious negative consequences. We practically lost our democracy a few years, and it's still in danger. We have these biases that were brought up earlier this morning in algorithmic biases, and there is a whole host of things that are potentially going wrong, and society is rightly worried about it. And so the way I'm thinking is, I think of technology in 3 stages. So when it's like very early stage, fundamental research, just transitioning to some interesting, innovative technology, there are few users, there may be like early adopter kind of things, and who knows where it will go, but that's where it is. In the second phase, you get more uptake. It sort of combines with some other technologies, and together they have a more powerful impact. New businesses come up. So I call that the middle stage. And then finally, the technology achieves what we may call the power stage. It becomes so ubiquitous. It becomes such a huge part of our life and society that it changes the power dynamics. It changes the power structures within society. It's at that point, it's too late. It's very difficult to then pull back in. And it's almost like, fighting a battle from behind. So what I'm encouraging people that I talk to is, even when you are at this very innovative stage, early stage, ask the following question. If you were successful beyond your wildest imagination, let's say you were just like unbelievably successful, the whole world adopts what you have done, what will be the consequences? Can you imagine the power stage for your technology, and will that be good or bad? Or what could be potentially wrong? What can we do now to avoid the bad and keep the good? Now, this is not easy. What I'm saying is not easy. In hindsight, you can see a lot of this thing for the web revolution. There is a lot of very interesting work that has come out to say, okay, where did it go wrong? Why did it go wrong? And I can share with whoever is interested some of that writing. I want to apply that lens moving sort of in a forward-looking, speculative manner, and especially teach our students, because they are the ones who are going to be creating amazing technologies of the future, to think like that in their research and innovation process. So just some thoughts on what we can do proactively and not wait till it's too late.
Anyone else want to comment? Okay, well then I'm going to go, David Buck.
I want to add to that just briefly that, I mean, and to me, what you're saying is long-term thinking. And I think that we have a problem with society to some degree, especially with young people, with being able to do that. I think it's a skill set, actually. And, you know, part of it is understanding people's motives and like circumstance to figure out how to motivate people to want to have long-term thinking. So just want to add that in.
Well, another quick addition is, as we're educating, if we center impact and having purpose and learning for good, that could actually help us focus what we should be doing in the future.
Thank you. So this is a question from David Butler, one of our organizers. And he asks, what in your view has been the most extraordinary engineering impact on society in your field of study? So we're trying to bring it back home to the theme of the symposium. But if you have thoughts about, you know, within mechanical engineering or chemical engineering or materials or computing, whatever, you know, what really inspires you as to, wow, I never would have thought how impactful that would have been. I mean, clearly carbon nanotubes, but and the internet.
The simple thing for me is I remember when Intel lost a lot of money on their chip line, and then they started putting thermocouples in all their chips. Simple thing, right? To be able to actually microfabricate a temperature sensor. None of the stuff we use today, the Zoom call wouldn't work without that. No electronics today would work without a temperature sensor inside the chip. And that happened for the first time, I think it was like 2005 or 2006. So something so simple, but so profound, because everybody has to throttle their stuff to manage the heat and kind of move the workloads around.
Anyone else want to comment on that in terms of, you know, when you look at things either that we've talked about or that we haven't talked about that we should have talked about?
I tend to look in the medical space because that's the space that I work in. But it's amazing to me, it's not even one thing, but the rapid advances that have improved the quality of life. People live longer. We're doing things more that we can use personalized medicine. I think that's going to continue, just this idea of improving the quality of life and the advances that allow us to do that. Even if you look at the way we were rapidly able to design a vaccination for a vaccine for COVID, it's technology that's allowed us to do that. And it was a combination of engineers, biologists, clinicians, immunologists, that the way that we can now cross disciplines and bring all that together for some responsible technology for human life, it's really, I think, significant. It's only going to increase.
So I'd like to offer that the NSF investments in MEMS and semiconductor devices have made possible very small, very low power radios that can discriminate extremely weak signals from a huge field of noise. That makes GPS possible. GPS is a tiny signal in a world of noise, and every cell phone has a GPS module. There's a lot of MEMS in there, including the F antennas that are done MEMS style. Just think of a world where you don't have GPS anymore. So you want to know where everything is. This is the technology that does it. And you can trace back the roots to investments NSF made in semiconductor devices and in MEMS in order to make all that possible. and I'll tie in the relevance issue. That story of relevance is not maybe appreciated enough, as in all these stories that we're telling here. So I just wanted to beat the relevance drum one more time. There's plenty of it there, but it's our job to point it out. You can't expect the public to find it.
Another area that I think is very, very encouraging is the falling costs of renewable PV, solar, and wind, and now storage. All of these, for us to have any hope of climate change mitigation, controlling the greenhouse emissions, we have to decarbonize the energy system, and these are very encouraging signs. And again, foundational investments by NSF, DOE, and other agencies are behind what we are seeing. And I think there's a lot more to be done, to be sure, but these are positive signs.
I want to just point out a little something about the internet. You know, we made a pretty dramatic headway from nothing to pretty much a full functioning internet in about less than 10 years. And one of the things that the NSF was responsible for then is they funded almost all of the early development of that. And it was pretty freaking remarkable how much we changed the world in a very short period of time. But the NSF is still continuing to fund a lot of the research and education networks today. And what we've seen today is 100 gigabits to a location, which is astonishing considering that 30 years ago, we were thinking of 56 kilobits is like super fast. So, you know, the NSF is continuing to make tremendous investments in this technology and using it for different kinds of science and engineering that will, you know, sort of provide sort of the highway for people to make these dramatic developments in other fields. And I think that the NSF deserves a lot of credit for keeping us on top of a really tremendous networked environment for research and education.
That's great. So I'd like to switch. Oh, sorry, someone else want to, Sarah?
Oh, and I was just going to add, and this is not a specific technology, but NSF's investment in people. And it is what has allowed all these technological advances to happen, whether it's been the graduate research fellowships for young graduate students, whether it's been early career funding over the years, it's changed names, support for all of the human capital that's out there in the academic environment. It's made a huge difference, obviously, on all the participants here and thousands of others out there. And I think that's important to acknowledge.
Yeah, that actually directly ties into the question I was going to ask. And this panel is an example, but you know, many of you have had pretty long careers. And the question I wanted to have the panel address was how across, you know, the last 20, 30, 40 years is we've made some progress in diversity. Again, this panel 20, 30 years ago would be all people like me. And now it's all, you know, lots and lots of different amazing people. But how, for those of you who have been in the university, have seen that change and you've been part of it, both as professors, but also in mentoring students, and what we can do to accelerate it, what we can do to do more. I know, Gilda, you've been working on this, obviously, you know, Paula talked a bit to it, but you know, we have more work to do. I'm on the board of a number of companies, and if you go to the commercial business side of this, we have tremendous work to go do. But I'm wondering your thoughts on, you know, what we can do to continue to accelerate making it a more equitable society.
I don't mind jumping in on that one. I think if we really want to move the needle, we've got to move past a lot of programs that are targeted towards individuals and move more towards systemic change. And what do we do that will actually change in the culture? So right now, if you look at some of our statistics, while it seems like we're doing better, we're flat. like the representation of those who have been historically marginalized is rather flat. The percentage of Black faculty who are full professors is like less than 3%. And so, and if you look at that, and women who are in those roles or who are in leadership roles, it's not enough. So we've had this approach to broadening participation that's more like, well, let's just increase the numbers. Like everything is about get the numbers up. And just when you say broaden, it's sort of like, well, if I get more in, we're done. The numbers went up. And so we need to move away a bit. You still have to get the numbers up for sure, but we need to move away from just thinking about increasing the numbers of people who are represented to how are they engaged? What is the quality of the engagement? What's the long-term path? How do we connect the dots? So for example, if someone does an undergraduate research program, they don't all end up where Bara ended up. Some of them you don't see again. And we're losing those folks, and we're not even paying attention to that. And so I really believe that a lot of it is that the environments are not necessarily supportive enough. The culture needs to shift, and we need to look for systemic structural things like a myth of meritocracy or gatekeeping courses. There's a number of things that we need to look at in concert along with the things that we have been doing to support individuals.
Do you think the funding agencies can help with this?
Yeah, I think the funding agencies could actually hold people more accountable. I can't tell you how many site visits I've been on for large and small grants. And you look at the piece that's around broadening participation, and you say, okay, that's good. Well, where are the people who are from historically marginalized groups in the leadership? Where are the people who are, representing the science? Like, I don't care if you got some folks of color and they're all off doing diversity. Where are the ones who are like engaged in the actual science? And if they're not making the mark in that space, take some of the money back, or, have some level of accountability. People know that they can get away with that part of the mission, that you can scrap by like, oh, I did part of that, or play a numbers game and not really show the quality and engagement and long-term investment in the scientific enterprise with a broader group of people. So I do think agencies can be important in holding people accountable and not just talking about it, not just saying, well, here's another program, here's another solicitation. Hold people accountable to what they're actually doing, because we do require evaluations, but then what do we do with those evaluations once we get them? So that accountability piece, I think, will help.
And I think related to that, Gilda, is how we evaluate the efforts that we're engaged in. So whether it's evaluating proposals or evaluating programs, but what is it we value, and are we valuing the right things? I think the other piece of it is, how do we provide a way to give individuals who have the ability the opportunity to participate, and not just evaluate those who have had the opportunity to get through a sequence of steps along the way. And then we've got marginalized individuals who just didn't have that opportunity, but certainly have the ability, and they never get the chance later on. That's kind of connected to some of the things that you shared.
I couldn't agree more with what Gilda and Sarah have said. And let me just add a few other dimensions to the issue at hand. Whereas there are examples of successes, places like Georgia Tech, I think, are great examples where things have gone better than many other places. It's not happening at the national scale. That is, somehow we as an overall system of higher education or system of universities haven't been able to leverage what places like Georgia Tech or UMBC or UTEP have figured out, or University of Washington. I mean, there are examples of success, but somehow when you look at the whole nation, like Gilda said, we are flatlining. I mean, and so I think, to me, we have to think different, and we have to think more of a systems approach And one of the things that I'm very proud of is the role I had in creation of NSF Includes, which asked the question of inclusion and diversity at the national scale. How are we working together to look at the whole system that goes from K through 12 all the way to the university and then post-university life in workplace, because all of us have a stake in solving this problem, and we need to look at the full picture. And I hope NSF Includes is a contribution to solving this problem at scale, because that's what the nation needs. And it's not one-off answers, right? I mean, I think that was Gilda's point, that the answers are not one-off. It has to be a much, much stronger systemic approach to this issue. And engineers are good at this, right? I mean, we are supposed to be systems thinkers, right? I mean, that's what we do. We all of us are involved in building systems of one kind or another and understanding systems properties. But in this case, I don't know if you have done a good enough job of looking at the overall system that's producing these outcomes that we don't like.
Yeah, I wanted to add to this. I've been spending a lot of time looking at economic development over the years. And the places like Georgia Tech are successful with Black faculty because there's a community of Black people in Atlanta that have financial stability. And I'll posit that science is only done by people who have a community that is not always worried about financial survival. That's how it's always been, back in the days when kings and queens funded science. And so when we look at the systems of our country, because I'm not talking about individuals, right? Because you can be an individual, be okay. But if everybody in your family, your community is kind of constantly looking for financial survival, you're going to be distracted away from science a lot. And so I think that is the fundamental problem. Like I normally, when George Floyd was murdered, I spent time thinking about this, and I spent time articulating some issues about the problems we have and how, when you look at where we put business in this country, and I've looked now, I said I was going to look back in May of 2020, and we're going to be publishing a paper soon, some great collaborators here at Georgia Tech, where we looked at the state of Georgia, and you look at any advanced manufacturing company that employs more than 500 people, and you look at where it's located and how that ties to poverty levels on a gender or on a race basis or cultural basis, however you want to look at it, the information is astoundingly clear that there's a systemic problem. And I think that how you can have a solution to that is just seeing it and then asking the question, where are you going to take that technology and capture value? And what's the impact of where you put it? Because people fund these things all the time. They give incentives for high-tech companies to come open up jobs here and there. And there are companies, NSF funded phase 2, they get money and they go and set up. And we don't ask questions about that. We don't ask questions about that. And I think that that's something that has to change. If we want to really have an understanding of what systemic means and not be searching aimlessly, we should look at the large employers in our country and where fundamental science turned into that and ask people some questions about that. And so that's something that's a big interest of mine, because I think it's just a matter of like, we are engineers and it is a system, and how we decide to look at data and how we collect data and how we try to make correlations. We can apply that to these problems. And we can make some advancements, but I just know too many PhD students and summer undergraduate students that fall off the direction. And I know why, right? And I mean, I can relate to that in many ways. I'm an anomaly in my community, and I can relate to that. And I can understand the sacrifices that people have to make to be an anomaly. And everybody can't be expected to do that.
Go ahead.
I just want to take a quick moment to tell a story from the olden days. in the early 1990s, we were hosting a variety of folks at our institution to teach them about how to be an internet service provider using SurfNet as a baseline. We were, I guess, pretty famous at the time, more so than a lot of the other networks. I don't know why, probably because we were really cool and mostly women. But I remember we hosted a group from an Asian country, and they came in, and we ran them through the paces. I had them talk to my tech expert, which was a woman, and my marketing expert, which was a woman, and myself, who ran the organization. And then they were going off to see other institutions to see how they also ran their internets. And they circled back through San Diego on their way back to their country. And the first thing they said to me was, "Thank God that we went to those other institutions, because we thought running the internet was a girl's job, a woman's job, and we didn't know how we were going to do that in our country." So would that be the same case today? Probably. I don't know that would be a hugely different thing. But, if you look at technology in general, I mean, in the Internet Engineering Task Force, which I talked about earlier, if you go to one of those meetings, I suspect that you would see about the same percentage of participation from women and people of color in that you saw 30 years ago. And it's kind of disappointing. But, getting along with people who are super techies is not for the faint of heart.
Well, related to that, and maybe this will be the wrap-up question, unless someone else has a burning question they want to ask. I'm very privileged. I grew up in a family where my dad was an engineer. He worked on Loran. So that was inspirational to me. And I also am old enough that I grew up in what I like to call the Apollo era, where we got the, human beings going to the moon and such. And so those two things, I think, had fundamental impact on me in wanting to be an engineer. A couple of you talked about this in your talks a little bit, about ripping things apart and liking to, destroy stuff, which is a great skill. But I'm wondering if all of you would talk a little bit about, truly from an engineering point of view, what, as you were growing up, what really inspired you to want to go pursue the careers you pursued? Oh, it wasn't that bad a question. Come on.
So I'll give a short answer to get it started. So I come from a family of Italian immigrant construction workers. My dad dug in the dirt with a bulldozer, and I watched most of the men in my family die by the age of 62. As a kid, I was determined. So here was my childhood dream, that I would somehow build a giant house that would take care of all these relatives that I saw who were suffering. These are people who sacrificed their bodies to their jobs. My grandfather lost a finger, someone else got his back broken, blah, 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 blah. So what drove me into engineering was I loved construction equipment. I became a mechanical engineer, and I was determined that I was going to learn how to design the best construction equipment that was safe. And that's a very deep and true motivation. It didn't quite turn out exactly like that. But if you want to ask, what is it that powered me through high school and pushed me through my first 4 years in college, which were not easy, and there was no one to give me any advice. I'm a first gen as well. It was the visual image of doing something that would allow these hardworking, working people to do their job and not end up broken at the end of their careers.
Great. Anyone else?
Well, I have to say, part of what motivated me was not having access and being given the impression that I couldn't do it. So I had no exposure to engineering, really. I started out as pre-med chemistry and realized I didn't want to be a clinician, and really a lot on my own, trying to understand how could I do something with chemistry with a medical application. I was like, oh, maybe I could do engineering, and sort of stumbled my way into engineering that way. And I chose chemical engineering because my bachelor's degree was in chemistry. And then when I got into chemical engineering, it's like, what are ways that I could use chemical engineering to apply to a problem in medicine? And so part of my motivation now is to like really help others be exposed early on to actually know what the opportunities are.
Right, thank you.
My story is not too unlike Al's or Gilda's. I'm from an immigrant family, raised on a small family farm and not a lot of resources at home. My mother was an elementary school teacher, so she had been to college. When I graduated or was in high school, the only thing they talked about for women like Millie is teacher, secretary, or nurse. I had graded a lot of papers for my mother. I didn't think I wanted to be a teacher. I didn't think I wanted to be a nurse and certainly not a secretary. I was good at math in high school. I happened to choose to go to Michigan Tech. I had never heard the word engineer. Well, Michigan Tech, it's about 80% engineering, but I went as a math major to start off with and then switched into electrical engineering. For a couple of reasons. One, I was told, because I didn't know anything about it. It had a lot of math in it, so it might be something I liked. And the other was I was told many, many times I couldn't do it because I was a female. And so that led me on the start of a career in electrical and computer engineering and a life as a teacher, as a faculty member, which was somewhat ironic.
Bar, you were going to say something, or?
Yeah, I mean, I'll share my story. I don't really share my story this story that I'll share. My grandfather on my father's side served in World War I and World War II. And the first war is in the Army, the second in the Navy. And I think in the first war, when he was in France, people used to ask to see his tail because they thought that Black people in the United States had tails, Black men, like monkeys. When he came back to the States, he could only get a job as a cab driver. And then he had 9 children. My father's the youngest of 9. So this is the Bronx, New York. And my dad's oldest brother, who he idolized, earned a Purple Heart in Vietnam. He jumped out of helicopters into live fire to run missions. And when he came back, he couldn't get a job. And the only job he got was working like as a numbers runner for people, who were involved in the mob. And he was murdered because something happened and he said something. And, he was a square guy. And so my father grew up in this environment where this was the life. And he was in his early years rejected the life of going to the military and did things, was a part of street life, things like that. But, through a series of events, that's too long of a story to share here, he, late in his 20s, went to the City College of New York because he wanted to just get out of that. And he told me when I was 4, he used to tell me stories like this, that he just went to the book of what jobs paid the most. He realized he didn't want to be a doctor because he didn't like blood. He realized he didn't want to be a lawyer because he felt he could be discriminated against. And he landed on this thing called engineering. He said, you know what? With science and engineering, I think I can go and have a good chance and I can go make arguments. And so he graduated from the City College with a degree in mechanical engineering at 30. He got out of New York because a lot of his friends had been killed and murdered for various things of the life they lived. And he went to Pensacola, Florida. His name's Anthony Cola. So he showed up to his first job in Pensacola where he met my mom. And the guy who came to interview him turned back around and went back in the office because he didn't know it was a Black guy. And then he came back out an hour and a half later and asked my dad to come into the room and solve a heat transfer problem on the board. There was a steady periodic heat transfer problem that my dad later in life had me solve. And he solved it and he got the job. So I grew up idolizing my father, not because he was a mechanical engineer, but because of his story and his perseverance. And I considered him a genius for his flexibility in life. And that's what I wanted to do as a result of that. And, I learned later that I didn't want to, work in chemical plants like he did. I wanted to do something a little bit sexier, like engineering and research. But I'm privileged. I tell that story that I'm super privileged because I stand on the shoulder of a giant, of somebody who changed the circumstances dramatically and gave me a vision towards a future that has been so good to me.
Well, I think we're going to leave it there because I don't know how you follow that up, really. Everything, all of you are tremendously inspirational. I super enjoyed today's session and learning about, first of all, meeting all of you and hearing your talks and your stories. It is certainly a testament to, NSF that you've had the successful careers you had. Of course, it's also a testament to each of you. So thank you very much for your participation today. And again, I look forward to hopefully running into all of you sometime in the future.